my name's Justin Baker. I am a solutions consultant out of the Midwest. Some of your faces look familiar. Either that's because I passed you around Starbucks or we've actually done work together. I have a passion for breaking things and playing with things. And the Raspberry Pi actually started as something I was using to help my kiddos. We homeschool. And being that I work for Oracle, I better step up and help them with some STEM projects. So it started with kind of a, I should be contributing, and quickly turned into something else. So quick show of hands, who's ever played around with a Raspberry Pi? Awesome. Okay, cool. And the folks that didn't raise your hand, I built this session so that when you're done, you could get excited and go start, right? So yeah, I'm a bit of a kind of a nerd and a data nerd, right? Doing analytics kind of stuff. And this is the intersection of both of those worlds. And it really helped me solve some of the personal quarrels I was having with my wife. So the backstory here is a couple things, actually. So we live in St. Louis. It gets cold, it gets hot. And I grew up in Florida where it was always just hot. So an older house and trying to figure out the optimal sleep temperature is something that everybody struggles with, right? There's a $1 billion industry and products to help you deal with this. And depending on what age you are, depends on typically if it's hot or cold for you and things like that. So for me, I like it crazy cold when I sleep, which is typically why my wife always says just go sleep in the basement, or maybe it was for other reasons. And for her, she likes it warm, right? So these were two things we were struggling with. And I'd always bicker in the summertime that it's too hot in here, and she'd say, go sleep downstairs. And in the wintertime, I would reverse that and say, it's great, nice and cold in here. It's 55 degrees in our bedroom. You go sleep downstairs. The other thing was I'd be on the road a lot, and I would start to get text messages that say the internet doesn't work, and I'm not there, right? So sorry, I can't help you. Go unplug it and plug it back in, right? Something like that. Most of the time I would get away with that. But it kept happening so much that when I had this Pi, I'm like, maybe I could use some sort of speed test, right? Let's add that to the list that Jarvis can do. By the way, if you hear me say Jarvis, I'm stealing that from Iron Man. That's the name of my Raspberry Pi. So I had these two problems, right? I had some sort of temperature thing going on in my house. Let's get some data to figure that out. And I had some speed issues in the house, or did I? Right? Am I getting what I'm paying for? This kind of thing. So I started doing research. I don't want to reinvent the wheel. So I found, it turns out, I wasn't the only one that was upset about their internet speed and their lack of accountability and the visibility in what they were actually paying for. This gentleman took it to a next level. So he created a tweet bot that would run a speed test on his Raspberry Pi, and whenever it was within some sort of threshold, right? So think of like red, yellow, green. I know what I'm paying for, so I know what budget is, and my actuals is whatever the speed test is. And so I can create some sort of kind of random list of messages and make it sound like it's me typing it. And when it's out of whack, I can start to bicker online directly to, in this case, it was Comcast. Sorry, Comcast, you're not alone. And so he would actually say here, so here's a tweet. Hey, Comcast, why is my internet speed 26 down and up when I pay for 150 down and 10 up? I'm in DC. And then he tags everybody in it, right? And not only that, programmatically created charts for the proof that this was actually happening. And I'm like, wow, that's amazing. That's awesome. I at least want to do this. I'm not doing this. I don't have any of this. All I have is now, right? It's slow. But has it been slow? Why is it slow? Is it because someone's on the video games or whatever, right? So if you're not tracking this information, you tend to start to go in your business. Okay, now we need to start to kind of drop the lines in the ground and start to listen and create some data and start to correlate so we have some sort of baseline. Awesome. So where did this is before I kind of decided on the Pi. What platform should I use? There's lots of home automation platforms, right? Lots of, Hey Siri or Hey Alexa and things like that. So I wanted a platform where I didn't have to, I just wanted an easy button. And I didn't find an easy button. What I found was there's lots of people doing lots of different things, which ended up being great. Sorry, my mic is too close. Ended up being great that the Pi is a well-known platform with lots of YouTube videos and lots of blogs to steal code from and play around, and people are willing to help out. So there's quite a community around this whole Raspberry Pi thing. So I started with the Pi. Here's the high level of where I landed. And so a couple different things. Who in here knows what if? I call it if. Some people will say IFTTT or IFTTT, right? I call it if. Okay. So you'll learn a lot of, good, I only have one person in the room, so the rest of you guys are going to understand what this is when we're all said and done. Okay, so we have this Raspberry Pi, and I brought mine. That's what you just saw me booting into. The Raspberry Pi has some RF sensors. The Raspberry Pi, right, what is it? So this is your what is it slide. For $30, it's an extremely disruptive technology. It's completely changed microcontrollers. People spending $3,000 for air-conditioned microcontrollers, I can buy $30, and if they die, I put another $30 one in, or chain them together, right? So credit card-sized computer, this little guy right here, and it runs Linux. It takes a flash card, so you can have multiple images, and when you want to turn it into a retro gaming device, you put in the retro Pi. If you want to, switch it back to doing the temperature test, I'd swap it in and out. So it's very versatile. If you break it, it's $30, and you can put a case on it. So it's perfect for my son to wheel it around, knock it off, all that kind of stuff. So then I needed to find a place to get these sensors, right? I do have an MIS degree, so I could solder a little bit, and I did a little, playing around with drones and things like that. But again, I needed somebody that kind of built these things for me. So it turns out there was a company, and you can go online and buy, this is a plug for them. You can go online and buy these RF sensors, and their whole thing was around building your home security system, okay? So everything from like your vacation home, if you're lucky to have one of those, and you're worried about flooding, they have little sensors to if the sewer backs up, right? So door sensors, motion sensors, heat sensors, temperature sensors, all kinds of sensors, and they ship them to you, and they're not built, which is the fun part. So when they ship them to you, they actually look like this without the sensor on them. That's actually what picks up the temperature. And you solder these things together. They give you the 1, 2, 3 guide to build these different things. And I was doing this with my son. And once you get to kind of this stage and you put the battery in, then you go over to the Pi. And I'm running that script now. We'll go back and look at it. When it finally heartbeats and sends you I'm alive, there's this huge connection, right, with a bunch of parts showed up at the door, soldering stuff. I don't even know if I even did that right. Oh man, I burned myself. I just trashed another iron, right? Am I supposed to be breathing this stuff? Probably not. Hey honey, make sure you take a picture of this. This will be great when we're older. And then, oh my gosh, it actually sent me the temperature like it was supposed to. So easy 1, 2, 3 guide, go get the sensors. And then it mounts onto the Pi, the listening part. Okay, so you have these satellite of sensors all over the place, and they all have different kinds, and they'll chat back what different kind they are, and it stores it in the Pi. Okay, so then it's all running Python. So quick show of hands, who knows what Python is? Okay, not a snake. All right, and it's all being done with Python scripting. The speed test is actually done with a CLI library. It's really, really simple. It's a shell script. You run it, and it dumps it out, and you can send the output to wherever you want. Any questions on that? Okay, and then we needed to get into kind of this piece, right? So we have the data collection. We've got the hardware problem solved. I've got the software, so I can route the messages. Then I wanted a place to stick the data. So I'm using curl, so I'm doing PyCurl, and I'm sending it to a web listening endpoint, for lack of a better term. I'm sending it to if, and I sent it to if because it was simple and easy, and I was just learning what if was, right, for home automation and doing a lot of kind of automation kind of stuff. But it actually lets me dump it out to a target. So I have, just imagine a CSV row. The Pi says, here's the temperature at this time. My name is bedroom, or whatever. And I say, okay, we'll go send that in Dropbox and append it to a CSV file. I'll come and deal with you in 6 months from now. Just keep writing. I'll turn the Pi on, right? I fire and forget. Since I do work for Oracle, instead of writing curl, I could have inserted it right into Oracle Analytics Cloud, because there is a REST API, right? So instead of me doing a REST API against if, a free service, I could have targeted one of my instances internally, right? So as a customer, you could leverage data sync. So to keep things really simple, I'm using desktop, data visualization desktop as a part of my cloud subscription, and I'm actually using the Dropbox connector, okay? So this looks like a convoluted way to get a simple message, but it's so I can showcase kind of all the integration points that you can do, right? So what is Maker, right? So this thing talks to Maker. If you guys don't know what if is, it's basically a way to automate tasks with lots of different channel types. So in this case, these are all my recipes, okay? So you'll have basically the name comes from if, this, then that, and an applet is kind of a workflow of building out these different tasks, okay? So if I get an email from you, then send me a text because it's very important. So I just stitched together two things that had nothing to do with each other, okay? In this case, I use my Raspberry Pi to get triggered from a value I send it, and then I say, then, if you get a value, go stick it in Dropbox, right? But you can do lots of really neat things with this. So to kind of prove the point out a little bit more, I was testing speed test earlier, right? So I'm in my Dropbox, and here is just a sample for all the geeks in here. So this is a web kind of service that's listening, and you guys can't read my key anyway, so don't worry about writing down my key and hacking my service. And so these are the values I'm sending in. In this case, I'm saying hi everyone and then bye. But when my Pi actually says what time it is, the value, the temperature reading, and then the name of the device, so I can tell it came from inside, outside, that type of thing, right? And this is the curl command you would use. So instead of me doing this to if, I could do this to Oracle Analytics Cloud, for instance, right? So let's go ahead and trigger that. I'll hit test. And you can do this all from their mobile phone as well. If I go into Dropbox, these are all the different kind of applets. I just got a text message that the trigger happened. So I can monitor my different feeds. And this was me playing around with it. So here's us, right? And it did the insert. So it's just doing an append in this case, right? So instead of formatting it this way, I format it as a CSV so data visualization can read it, right? And I connect with the Dropbox connector. Go check out if. There's lots of things you can do. I would just barely use a very piece of it. Yeah, so in this case, we are doing a trigger, but I could also send it a message, and then it would make a request on my behalf to a completely different service. So lots of really, really neat things you can do here. Okay, I just walked you through that piece. And then, obviously I work for Oracle, so I'm going to plug this. So have you guys played around in Oracle data visualization at all? Okay, awesome. Yeah, I know you stopped by the booth. Good to see you. So a couple things, right? This isn't going to be a deep dive data visualization class because we're talking about IoT and the intersection of these pieces, so we won't have time. At the end of this, there's another session that's coming up later today from our very own ninja visualization at Oracle, Philippe Leon. I recommend you definitely visit that. Actually, Philippe's hiding back there. And you'll get a deep dive on what is data visualization, what's new with DB 3.0, and a variety of other really, really neat things. So for us, data visualization is our self-service experience. Do we have any Oracle BI customers in the room? OBIE customers? Okay. All right. So this is kind of rearing its head in the 12c experience and in the cloud. It was born in the cloud. And you think of like the clicks and the tableaus and some of these kind of visualization tools. This is our answer to that, except it runs within our governed environment, right? So we can leverage all your subject areas you guys have always built, all the curated data, but also let users bring in their own data. In this case, I'm bringing in my Dropbox data, and I never talk to anybody else, right? And I can blend that with curated data without ever talking to anybody else, right? And Philippe will do a lot of really neat things. So this is our visual experience. It's very self-service, 40 plus connectors, and it allows you to tell stories, and that's what we're going to do. Okay. For those that are interested in how the Pi stuff actually works, when we're done with this session, I'll toggle out, but for now we're going to stay in DV for the rest of the session. So I've been busy with lots of visualizations. So this is the home page of data visualization. In this case, I'm using the desktop version, which is the kind of personal edition. And I do lots of customer demos and Boy Scout stuff with Pinewood Derby and all kinds of neat things. So not just work-related things. And I've built a couple of these two pieces. So you remember I had the temperature challenge in the house, right? So I was collecting data on that, and I also had a speed test thing. So let's go through the temperature one first, because that was more of a heated discussion in my household. So I have kind of gone through this journey, and I've built out the story. So as I build and analyze the information, I can create kind of a tile or a slide, right? And we're going to walk through these different insights. So in this case, this is actually the thermostat. So I have 3 sensors in the house. One outside, right? I have one at the thermostat, what I'm paying for, and I have one in my bedroom. Because the big bickering was, why is it so cold here, but the rest of the house it's not? Or why is it so warm here, the rest of the house it's not? So I just needed those basic three. So this is a year's worth of data, so last August up until probably last week or so. And obviously there's some interesting things going on around, kind of some dips in the temperature. As we move forward, I start to layer in some other reference points, right? So the funny thing about when you get into IoT, you get into sensors are very chatty and they don't always work. Okay? So in this case, my sensor was doing great. I thought I was fine. And I just leave this thing running. And then all of a sudden, it just decides it doesn't want to send me data anymore, but the the thermostat is still giving me data. And then it just dies. It's still giving me data. Right? If there's a space here, it's offline. So the sensor all of a sudden says, and this is February, so the sensor says, I am negative 450 degrees Fahrenheit. And I start freaking out. But no, we're still good, right? And then it says, no, I'm good. And then it goes back to being horrible again. And then when I had it at demo grounds, it was actually back up and working. So the point here is, one little sensor probably isn't going to cut it. You're going to need an array of these sensors. And then if you have an array of these sensors, then you're going to need to figure out a way to federate that data together and make sure you have a nice normalized kind of test. You're getting the right information, right? In this case, we only have 3, so I didn't have any redundancy. And the reason why it went offline is we had a huge snowstorm, and I didn't put this in a nice protected case, and it killed it. So, and also weather does a work on batteries, little button batteries. So, when I first looked at this, I'm like, what am I going to do? I have a presentation on this. Well, it turns out that's my outside temperature, so I can go to the weather service, and I can go to my exact zip code, and I can go and pull the daily averages. So now I need to do a data patch. So now I'm scrambling. So what is a data patch? So built into data visualization is the ability, and this happens all the time when people are working with this stuff, is the ability to do data wrangling, or ETL, or change the data, merge the data, fix the data. So we call those data flows. And so I have 2 that I built here. So here's one on temperature data. So I need to fix that data. So what's cool about data flows is it's self-documenting. So here's the data from Dropbox. Okay, and it's really simple data. What time it was when the sensor said send the value, the actual value in Fahrenheit, and then the name of the sensor. And I have these documented so I know which one's which. Okay. And that negative 450, some of the data that's in here is good, and some of the data is bad. So I need to splice this stuff together. I started with something that'd be really easy. Just drag and drop a value with some time series data and look at the charts, and I'd be able to say, ha, I was right. It's actually really, really hot in the summertime. Now I need to go back and figure this out, okay? So I took the national weather data, which is and they give me the highs, the average, and the low, and it's at a day level. I said that is now going to be my sensor 91, which is actually outside, so I could join the data back in. Then I joined the data together on date, and my date's at different grains, so if you can think about that being kind of a challenge. It's things at a timestamp, things at a day level. So I splice this data together on date, and then I add a bunch of columns so I can do more analytics. So what data flows let you do is enrich the data. In this case, I'm taking a date, and then I build kind of a time hierarchy. So give me the hour of that date, or of that timestamp, give me the year, the month, the week, and all the fun things I might want to slice and dice it by. So I'm actually taking a very simple data set, and I'm adding to it. And then I'm fixing the data, rename some columns so it makes sense. And now those 3 columns have turned into basically a whole time hierarchy, as well as some averages. And then I pivot the data so I can do some analytics on it. So when we go back to and I run it, when we go back to our story, I need a way to patch this data, right? So in this case, what I actually did with data flows is I took this curve and I mended the rope. So all these little gaps, that right there is where I spliced in the data from a completely different data source to smooth out my temperature data. And then in this case, I'm just going to ignore this altogether and just use that average. Does that make sense? So I've now fixed this IoT data that I thought was going to be amazing and cool, and it turns out that I have to do lots of work to use it, which is real world. So now I understand what's going on with the outside data. So I'm looking at my thermostat. I see those dips. Now I have context. It got really, really cold last winter in St. Louis, and it affected both the bedroom and the thermostat. So altogether, my house got cold, and it actually, these are averages, so it actually got down to negative and caused these big dips. So right away, I'm already thinking, oh, my wife an apology, because she started off with, you think it's hot in here in the summertime, or in the wintertime, it's 20 degrees cold in here. Right? I don't want to hear you gripe about it. Well, she's right. So I owe my wife an apology when I get home, that these dips right here, we've got something going on in our bedroom. But I have more of a hard time personally, and my bias is I was looking for, in the summertime, that this delta here, this is the 15 degrees colder, I was hoping that I would see the opposite swing in the summertime, because it's always so cold. The reality is it's not. So in the summertime, it's actually, the bedroom and the rest of the house are all exactly the same. So then I'm wrong again. And so now my bias of looking at this data is searching for me to be right, okay? And that brings up an interesting thing that I see customers doing all the time. They will start with a gut, right? They'll take their data, and then they start to try to validate what they want to see, and the data is not showing them that. And what's cool about data visualization is it lets you fail fast. So I can quickly go, I was wrong, and I can keep trying to use as much as I want, but the data is not lying here, right? Because I'm pulling this from a curated source. And now I can share this insight back with my wife and realize that she was right about some things. My wife's going to hate me when she sees this video. So this is layering further information, right? So instead of doing the visual math here, here's actually the delta between the bedroom and the thermostat. And then these are all negative numbers, which means it's always colder in my bedroom, even in the summertime, than it is versus the rest of the house. So the hole keeps getting deeper here. And right, so to zoom in a little bit further, same exact data, but you can really see the deltas, and in some cases, it gets pretty cold. So that should be making sense. Okay, so I zoomed down and I chased the rabbit. And the cool thing about DataViz is that we have these different plugins that are out in the App Store. And so I'm using basically some box plots like you would typically do on like high-low and stocks to just zoom out and just find out what month do we actually have a lot of variability. Obviously I've figured out that it's the extremes. It's the winters and it's the summers. The reason why, so human behavior wasn't consistent through this whole entire test, right? So I'm doing an experiment, but I don't really have a control. And what I know what was happening is my wife stays up later than I do, and she likes the door closed when she comes to bed. I like it, I'm the security guy, right? I like it open so I can hear what's going on. On the 1979 ranch, we have one outlet into the bedroom, okay? And what was happening was she was closing the door in the wintertime and actually causing this delta. So the airflow, it's very simple, right? And in the summertime, I learned this as I was watching this, and these lines get tighter because I started leaving the door open. Sometimes I'd wake up in the night, or I'd say, let's leave the door open, these types of things. And I was able to sleep a lot better simply by leaving the door open, right? So we started with this really complicated, I'm gonna do this IoT project, and I'm gonna use all this technology to solve everything, and the fix was just leave the door open. Interesting enough, when that door shuts, and this is a heat map of temperature, okay, so basically the darker numbers is when it's getting warmer. And this is military time, so it kind of loop back around, right? So we're going to bed right here, door's open this whole time, go to bed, starts warming up. This is the winter time, okay? And, well, actually in this case it's actually dropping off because it's winter time. And then over here, it's the opposite effect, it's warming up. So as the door closes, lack of airflow. And there's lots of ways to fix this, right, with technology, but I just leave the door open. And just to plug some other visualizations, right, so when it's all said and done, it wasn't about the temperature. I started on this whole thing. It's always different in our bedroom, and that was the metric I was hung up on. That actually wasn't the metric I really should be looking at. The real metric is what it feels like in my room when I go to sleep. And so this is the maxes for these different months. And it's in the 70s. I don't have anything to gripe about. If I wanted to kind of figure out from a heat perspective, yeah, it's warmer in the summer. It's colder in the winter. So I will be leaving the door open. But the bigger challenge here is the optimal sleep temperature, if you do some research, is about 68 degrees. Right? It's like a doctor's office or a dentist's office cold. And it's like 78 degrees, 79 degrees in the summertime. So I'm going to go back, and yeah, you're right that in the wintertime it's really, really cold, but in the summertime it's really warm in the whole house, right? Well, she's going to say go sleep downstairs. So I owe my wife an apology. We don't really have a temperature issue. We just need to leave the door open. So the second thing I was chasing, if you remember, was internet speed. Same challenge. Same exact architecture. Speed test runs, says I ran it this time, this is what the value was, okay? And it captures 3 metrics. You guys have all done this on your phone, the speedtest.net thing. That's what I'm using, but there's a command line for it. So again, some changes happened here. So this is interesting. So in St. Louis, we have a couple different choices. It's basically really, really fast internet or decent internet for a lot of money. And so I was paying, I don't know, $40 a month for like 20 meg down or something like that. And it was very, very consistent on the upload, right? You can tell they were throttling me pretty hardcore. And then on the download, it slowly started getting worse. Oh, and then they brought out a new machine because I got hit by lightning. And it slowly started getting worse. And then I started checking my bill, and it went from like $40 a month to like $80 a month. I'm sure that's happened to you guys before because you're off the discounted rate or whatever. So I called them up and I said, what can you do for me? And they said, hey, we'll bump you up to 50 meg down, and we'll cut your bill in half. I was like, done. That's all right, fine. We'll do that for another year. So they came out and they put in a new machine. And I'm standing there running the speed test on my phone, and I'm not getting 50 meg. Oh, it's over wireless. I'm like, I should be getting 50 meg, okay? You just call it in. So I'm like, all right, I'll just run the Raspberry Pi. And I've been doing this the whole time, and he didn't know it. And I turned my sampling rate to every 10 minutes from an hour to see if I could really get some data. And I still wasn't this trend still goes down even though my max is now 50. And it's all over the place. It's inconsistent. Well, another thing that happened, and my ping actually got more consistent. My upload was screaming and continues to scream, but this is what I was having challenges with Netflix and all that kind of stuff at night. So I went and made 2 changes in the middle of a investigation. So I bought a mesh network. Do you guys know what a mesh network is? It's this new, okay, so hotels use them a lot. It's one node and it talks to lots of different nodes. And so as you move through the mesh, the nodes hand you off, right? So I'm talking to him right now with my device, and as I get closer to you, it leaves him alone and continues this email, right? So it's a mesh of these devices. Instead of having one big loud one, and as I get further away from it, it gets worse, we can create these spheres and they all overlap, okay? So hello, Linksys, my old friend. Spent a bunch of money, went all in, homeschool, make things go faster, and I kind of made them go faster, but I created a bunch of variability. So sometimes it's fast, sometimes it's not. So I thought I had a fix. I still don't have a fix, and I'm chasing this ghost in my network. It turns out my Raspberry Pi was hardwired through this whole experience, and then I went wireless to test out, right? Turns out the Raspberry Pi doesn't really like to play really well with my mesh network. The rest of the house, it's screaming at 50 meg. So the point of this was, I thought I had a good metric, right? I'm staring at this in your business. You think you have a good metric. I'm biased to that because I set it up that way. And it turns out I was actually blind because although I think I have an issue here, the rest of the house is like, this thing's great. Thanks, Dad, right? So the Raspberry Pi helped me kind of navigate through these different experiences and these different challenges over a year. And there's many, many different use cases for a Raspberry Pi. And if I ever need to download anything or schedule anything, especially for Oracle new images, I always schedule them when no one else is running the internet. And you can see I'm still I thought I wasn't getting what I was budgeted for. This is the line for budget. Still a big gap, but it turns out I'm actually okay. Just the Raspberry Pi has a hard time with dealing with the mesh network. It freaks out. It likes to run different things. So, what I've walked you through today is a very simple example of using a disruptive $30 piece of technology, right? Didn't know how to solder anything. Got on YouTube and a couple things and pieced it together. and used some starter code to work with data visualization to really start to gather what's going on around me in my house, right? At the same time, teach my son how to do more fun things with data, and to bring it to here and hopefully light a fire that you guys that you know what a Raspberry Pi is, right? And you want to actually start to kind of contribute to this whole piece, okay? So how does this relate to when you go back to your office? Download data visualization, right, off OTN, play around with it, go to Philippe's session, and start to bring in lots of different data and solve some of these problems that are in your organization. And this is, make sure you check out Philippe's session. I think he's the last of the Mohicans on the Oracle train. You have any questions? Yeah, what's happening?
So, are you using two separate Raspberry Pis for your temperature test versus your speed test?
No, it's the same one.
Different program?
Jarvis does the whole thing, yeah. So you can run asynchronous, right? So it's a Linux platform. So I start a script on a cron job. Because the other thing that was happening is you had power outages or the internet would flake and the Python script would freak out and disconnect and just sit at a terminal like it crashed. And I would come in and have no data for like a month. And so, so you had to add in the auto recovery and all those extra pieces. So, it's one Raspberry Pi. I don't know if you guys heard the question. So do I have multiple Raspberry Pis? No, I have one, and it's running multiple scripts. And so it's able to do both. It's able to multitask. Yep.
What was the frequency of your pings?
The frequency of how often they chat out, I believe it's set, and they're flashed into the device. I believe it's set to every 5 minutes. And actually, let's, while we're doing questions, I have it running right now, and I have one of the sensors in my pocket. So you can see some temperature differences. So I have it in listening mode right now. It's basically in a never-ending while loop. And it's listening for these sensors. So you guys, afterward, you can come up and check these out. I have a Bluetooth keyboard with a track mouse. It's all connected into this device that is not, there it goes. I don't know if you guys can see this, kind of hard to see. Every time one of these sensors chats out, it says, I am this type of this sensor, and this is my value, and this is who I am. And so I grab that data with Python. So I grab that data. So I mentioned that company, right? When you buy the sensors, they give you a whole library of Python stack. And then I tweaked it so it would write curl, because it actually wants to write to their server. And you have a dashboard. You can set up. I can tell someone open the front door. It can send me an alarm. It can trigger an alarm. Lots of fun things like that. So I modified this code, and it's horribly shown on the screen. But basically, I'm doing a post of 3 values. Value 1, value 2, value 3. You can kind of see that there. And it's JSON, and it's doing a post. And the triggering is actually triggered by the device. So when it's listening, that's the event. It triggers it, and it runs the post immediately. So it just sits there and listens the whole entire time, and it just keeps hammering it like a Geiger counter, and starts writing those out to Dropbox.
So do you have a web service behind you? Is it a RESTful service?
Yes. So what's happening is up on if this is the endpoint listener. In this case, I'm actually not writing the case scope. I can make this whatever I want. It'll create a separate folder in Dropbox and then dump whatever the value is that I have in there. But this is actually the REST service I'm talking to. It's hosted by if then and that. I don't know if you've played with that website before. It's free to play with. It's a lot of fun. It's actually great to use. One of the big use cases would be like eBay. If you're looking for a specific product on eBay, you can give it a search string. It'll troll for that, and when it finds one, you can say, text me. I did that, but then it found like 30,000, and I was like, stop, turn it off. So you might want to test fire that into like a Dropbox folder first, or an email, something that's easy to delete until you refine the search. But it's pretty to use. It's a lot of fun, and there's actually, you can build your own applets. You can get in the developer network and build your own applets. So yeah, here's using curl, right, to do a web post and send it value high, value 2, everyone, value 3, bye. In my case, my pi isn't saying hi, it's saying temperature, the value of the temperature sensor, and the actual ID, who it is. Like 91 is outside, and so forth and so on. And I could have hundreds of these, right? So think of in your home, right? If you have like humidity in the basement, St. Louis we have basements. In Florida we had mildew problems, right? So lots of different fun little sensors you can buy. You get to assemble them, or you can buy them assembled from them. And then once you put the battery in, they're already pre-flashed to shout out what kind of device they are. And then the Python code knows how to catch it, and then you can tweak the message and do whatever you want with it, which is in this case, that's what I'm doing. Yeah?
So once the file reaches Dropbox, how do you go? Do you have a database on that?
Yeah, I pull it directly with DV. So actually, I'm using a data flow in this case, but let me just show you. Let's do it on the fly. We'll do it live. So DV has a bunch of different connectors. These are the data sources that are pulled from. Create new data source. Connect to Dropbox. So ahead of time, I've said, sign in as me at Dropbox. So I've created a connection, right? That's how that magic happens. So now I'm in my Dropbox folders. They should look a little familiar because we were just up there. It creates this folder, if and then that. And then maker is the channel that I'm talking to. Here's the one that I was talking about with the eBay stuff. And then here's the Kscope one that we built. And in this case, the file type, it can't see it yet. If I was using 3.0 like Philippe is, it would see it. So let's do, I have multiple projects here. So here's the RF one for a temp sensor. And here's the CSV file, right? So it's just appending to this file, right? And then I connect to it. So right now it's trying to parse the file. So let's do that. So you see the query running at the top. It's connecting to Dropbox. And then it pulls back the file. And then I'm using data flows, that the process, the ETL process, I don't know if you saw that part, to then automate this. So go up, connect, make the connection, pull it down, add all the extra columns, right? Pivot the sensor data, splice in the bad outside data because my sensor died. That whole process is automated. I hit run, and then my DV project updates with all those insights. So if I want to monitor what's going on, I just run the data flow, and then I open DV, and I can see things move. So it's very simple, right? But I could have written this directly to Oracle Analytics Cloud and skipped this whole file-based piece and had more of a streaming feel to it. I just didn't have my OAC instance always on. Dropbox is always on, so I could just dump it there for now.
When you stream like this, when you have hundreds of users all streaming, how do you handle that?
So the Oracle solution, because I remember we were talking at the booth earlier, he came by and he has this really cool IoT, lots of data kind of barrage. And so Oracle has an IoT cloud service that's designed specifically to talk to millions of devices and then do what I'm doing where it aggregates it and it'll send it to Oracle Analytics Cloud. So the integration, Oracle's figured out the integration to take sensors and route it right into, say, dashboards. And there's lots of, different services and different pieces of pre-built integration. Have you guys heard of the IoT cloud service? We have now. So if you go to Oracle, you get oracle.com, cloud.oracle.com, you can go and check out the IoT cloud service, right? I'm just showing you a little piece of the iceberg here, but there's lots of different services that help automate all this stuff. I took a consumerization approach, something you could do at home, right? But if you guys had an IoT project, you could pilot out the IoT cloud service.
The reason for the question is, let's say if you're streaming it and you have a dedicated connection from your device to the cloud, right? How many parallel sessions can the cloud actually handle?
Millions, yeah.
Oh, really?
Yeah. Well, you pay for it, right?
Yeah.
So it's you might have multiple instances, right? And you're paying for all those. They charge. I believe. I don't. So I'm on the sales side, right? On this engineer sales side. I believe they charge by the number of events that they're listening to. So there's a price to how much you want to scale on that. But I would start small and extrapolate it, right? For the use case he was talking about, I don't remember how many sensors you had, but start with maybe half or whatever, and extrapolate the cost and how much data volume would actually happen during your POC. In my case, it's a good point, because in my case, I didn't know how chatty these things were going to be, because every time I added a sensor, that's every 5 minutes the sensor on its own would start posting. And so I had this exponential curve as I started adding sensors. And Dropbox, I didn't exceed that limit for Dropbox. So, yes?
You talk about manually putting in when your device quit. Where read the CSV file in here. When you manually had to put in those other temperatures, where is that data stored in?
Yeah, so
Or is there a database under the covers, or how?
Yeah, so it actually stores it in something called the XSA cache. So it creates this concept of a data set. If I had been streaming this data, I would have just loaded into a database, right? And that data would have been static because it's historical data. Pulling the National Weather Service for St. Louis, right, min, max, average, that's a one-time load. So I didn't need, in my data flow, I dumped it to an Excel file, right? And then in my data flow, you saw me join it. So this, we go back to data sources, and we go back to the temp data. So this is connecting to Dropbox. This is connecting to that national weather data, which is a spreadsheet that I already loaded into DV. And so now it says I see two data sources. This one comes from Excel. This one comes from Dropbox. And I know how to connect to Dropbox. And then the data flow lets me automate all of this into this flow. Right? To do this join and this merge, you can do all of that in DV on the fly. You don't have to use a data flow to do the merging, two different data sets, two different things together. I did it because I needed this automation to come down off the cloud. If I was streaming it to a database, I could skip that step because when I hit refresh, right, it's just going to pull it in. So there's ways of making this a lot more streamlined. I figured I would start with something that was pretty easy to replicate, right, batch-oriented pieces. Any other questions? So go get a Raspberry Pi. They're like $30. You'll spend more money on the sensors. It's a lot of fun, and it has lots of different use cases, not just nerding out with data, but that's what I chose to do with it. So thanks for coming. If you guys have any other questions, feel free to come up.